Okay, a couple more properties before we get on to equations. This one we can kind of figure out. If I ask you, this one should hopefully make sense. The log base a of a to the x. That is, when we did logarithms, if I ask you, what's the log base a of a to the x? You would say, well, a, right? If this is, we gave this guy a name, we usually call it m, right? We say, okay, a to the m equals, or a to what power would give me a to the x? Right, and the answer has to be x, right? This m and x would have to be the same. So in other words, they cancel each other out, right? If the base, and we've seen this one before, now officially it's a property, the log base a of a to the x equals a. And we also saw that when x was 1. The log base a of a, right, ask yourself, a to what power gives you a would have to be 1. All right. And there's a similar property where the log is up in the exponent and it goes like this. So I know that's a weird looking expression, but it's the exact same concept. A to the log base a of x, those also would cancel each other out and leave you with x. Okay. So look out for that property. So these are all going to be pretty easy. 4 to the log base 4 of k. Okay. E to the natural log of 5. Remember, e the base of natural log is e. So that's 5. And here, common log without a base, is base 10. So 10 and 10 cancels out, leave you with the exponent, 7t. Okay, finally, we made it. Exponential equations. The reason we're studying these properties, so we can solve exponential equations and logarithmic equations. 2 types of equations here, so be careful. Try not to get them mixed up. First question you ask yourself when you're solving these equations is it exponential or is it logarithmic? And that's easy enough to see just by seeing if there's a log in it. If there's no log and there's an exponent in it, then it's exponential. Okay, so that's the easy part, but the harder part is remembering which method to apply. If I have an exponential expression, I'm going to apply an exponential equation rather, that is where your x is up in your exponent, like those 2 examples. There's going to be one of 2 methods. Method 1, I'll call this the easy method, or the easy type of equation really, and most of them will not be this method. So this is method 1. Write both expressions using same base. Okay, and then method 2, take log of both sides. Most of the time we'll need to use method 2. Most of my examples, most of your homework will be method 2. I'll show you method 1. It's like a special case. This is a really special equation because of the relationship between 2 and 32. If I recognize I can write 32 as, so I won't change the left, but the right side of the equation, I'll recognize I can write 32 as 2 to the 5th. I recognize that as a special number. It's a power of 2. Then I can just, if 2 to the 3x minus 7 is equal to 2 to the 5th, we can just drop these bases, right? We can just equate the exponents, and I end up with 3x minus 7 equals 5. And I got a basic linear equation to solve. No problem. Okay. So look out for those. If you're able to manipulate both sides of the equations so that they have the same base, then rewrite as the same base and equate the exponents. No problem. Now, what if I cannot do that? This is my method 2. So let me give you here's an example. 3 to the first power is 3. 3 squared is 9. 3 to the third is 27. You're never going to get a 20 out of that. So you can't do method 1. So you have to do method 2, take the log of both sides. So let me show you why this works. It's based on our properties. based on the properties that we just talked about. If 3 to the x equals 20, then what I'm going to do is I'm going to take the log of both sides. Now it's my choice what base to use. So I'm going to use, well, let's do base 3 to start. Why did I choose base 3? Because I know from my properties the log base 3 of 3 to the x is x. Right? And that's it. That's the algebra step I'm using to solve an exponential equation. Let me repeat that. The algebra I'm using to solve an exponential equation is to take the log of both sides, because that kills the exponential piece. In this case, they cancel out. It leaves me with x, which is the goal. And there's my answer. Log base 3 of 20. That is acceptable. I'll take that. Now, usually we don't like these weird bases in our answer. We like 2 bases. And if you look at your calculator, if you have a scientific or graphing calculator, there's 2 bases on your calculator. One's the log, the common log, base 10, and the other one's ln, the natural log, base e. So let me try this equation again. I'm going to solve this 3 times. So I'm going to start over. 3 to the x equals 20. Let's take the natural log of both sides. Okay, the natural log of 20, just like log base 3 of 20, they're not the same number, but they're just a number, right? If we figured out what that is as a decimal, it's just some decimal value. I'm more interested in the left-hand side of the equation. What's the natural log of 3 to the x? Now these don't line up. So this is not just equal to x like it was here. But I can use that property that we love, that I say we use in calculus a lot as well. It's really helpful here in solving equations. It brings the exponent down. Okay, so now I have one more step to do if I didn't take log base 3. Remember, just make sure you're treating these as one number. Don't ever divide by ln, right? That doesn't make any sense. It's got to be the ln of a number. And then I end up with this as my solution for x. X equals the natural log of 20 over the natural log of 3. And that's correct. I'm going to do it one more time. And you're not going to have to do this. I just want to show you something here. That is, I'm going to do the same one. Same equation, start over. I'm going to take the common log of both sides. So again, I'm using this property. They're not the same base. This is base 10. This is base 3. So it's not just x, but the x does come down, becomes a product. X times the common log of 3 equals the common log of 20. And I divide by this number, the log of 3, and I get my answer. The common log of 20 over the common log of 3. Okay, so that means, I'm going to do this one in a second. That means that x equals the log base 3 of 20. That's correct if we took the log base 3 of both sides. The advantage of that is that it's less algebra. It's one less step. And the other advantage is we like this property. Bases line up, gives me with x. Gives me x directly. We don't like that property because that button's not on my calculator. It's just a base we don't use that often. So if we decided to use one of our more common bases, or the ones that we're more familiar with, or the ones that are on our calculator, we would have got the following answer, or this answer. And they're all the same thing, all right? And you can test those on your calculator. You don't need to, when you do your test or your quiz or your homework, you don't need to give me all these different answers. Just any of them's fine. But this is what I was talking about with I can now talk about the change of base formula. So if we ever have this weird base 3 and I wanted you to change base, well, let me write the formula. Let me write the formula down because we've already seen it twice in my presentation and I skipped it. It looked like this. If you have the log base a of, no, it was like if I have the log base b of m, right? And I didn't like this base b and I wanted to change it. I wanted to use my calculator maybe. Or if I had the log base 3 of 20, I don't know how to plug that into my calculator. So if it's the log base b of m, then what you're allowed to do is say the log base a, pick a different base, and then what you're taking the log of is on top. And then on bottom, the log base a, same base, your different base that you're choosing, and then you actually take the log base a of this base, b, and that's your change of base formula right here. And that's from previous slides. Okay, and the reason I skipped that is because I'm just showing that works right now, because we just arrived at the change of base formula by solving this equation this way, and then we did it this way, and then we did it this way. We did 3 different ways, taking 3 different bases, and we decided they're all the same, right? So you can see that the log base 3 of 20 is the natural log of 20 over the natural log of 3, which we got from solving the equation. But now I can use that to demonstrate the change of base formula, because look how I go from here to here. I can change my base to the natural base, and this number goes on the top, and I'm taking the log of this number in the bottom, and I can get there that way as well, okay, instead of solving an equation multiple times. All right, so when do I use the change of base? Well, I would use it for this statement, right? Because on most calculators, there's no base 3. So you could say, well, wait a minute, I don't like that statement. Let me pick a different base. How about the common log? And then the common log of that guy goes on the bottom. And whatever that is a decimal, is what this is as a decimal, because they're the same thing. Okay, so hopefully that made sense. 3 answers. Like I said, any one of those for me is acceptable. Just be careful when you do My Math Lab what they're looking for as a solution. A lot of times My Math Lab will take multiple answers anyway. Okay, let's do the next example. So again, that's the same method. Think about, how did I solve that? I took the log of both sides. Base is my choice. That's what I'm going to do with the next one. However, I want to first isolate the exponential piece. So I got one quick step of algebra. And now I'm going to take the natural log of both sides. Okay, natural log of both sides. Why natural log? Well, 2 reasons. One, it's one of the bases that I like, natural log, common log, and it agrees with base e. All right, so that means I can apply the property, same base, and it leaves me with the exponent only. Okay, and then, so does that make sense? The natural log of e to some power is just the power. And what happens when we apply our property? We're back to an equation that I know how to solve. That's a linear equation. I know this looks a little not linear because the natural log expression, but remember what I keep saying, the natural log of 25, plug that into your calculator if you want. That's just a decimal value. I usually do it all at the end. In this case, so we'll have to think about, do I want an exact answer like this one? This answer here in green is exact. It's exactly natural log of 20 over natural log of 3. It's still in fraction form. Or in other words, I didn't plug anything into my calculator. In this case, that's the exact answer. But typically, if you're given a decimal, right, there's a good chance this is some kind of application problem, then you're going to want to give me a decimal as an answer. So I go to my calculator for this one. I'll type in natural log 25, and then I'm going to divide that by 0.08. Make sure that's not all in your natural log parentheses, right? Because it's natural log of 25 in the numerator divided by 0.08, and I get 40.235. I'm going to round that to the first decimal place, 40.2. See if you get that on your calculator, okay? Solving exponential equations. What's our method? Method 1, if it looks like this or this, 64 is also a power of 2. We do method 1, which I don't use too often. 64 is 2 to the 6th, right? And then I can just equate the exponents, and x should be 6 over 5. Easy. Usually we're doing method 2. Take log of both sides. The log base will be your choice. Here I did it 3 ways. I did base 3, and then I did natural log, and then I did common log. And they're all correct. This is about as hard as it gets. Doesn't get too much more difficult than this one, so let's do it. In this case, I have 2 exponential expressions. So I'm going to stick with base, or the natural log, and see what happens. Okay, so I'm going to take the natural log of both sides. This could get ugly.